Okay, so this is a lecture on 9.2 part 1 where we're going to look at limiting reactants and percent yield. Now, limiting reactants are reactants that run out first, and they control how much product is going to be made in a chemical reaction. So your limiting reactant forms the least amount of product, and I'll explain that in a second. But the the reactant that you have the most left over, that's going to be called your excess. And we are a little bit familiar with excess because we've seen word problems say in excess of fluorine gas or whatever compound that they're looking at. That's a substance that's just not used up completely in the reaction. Okay, ignore the example. Your book reads about zinc and hydrochloric acid and the byproducts of it, so you can read that on your own. But let's just take a look at this real-life example in honor of school spirit, since we're at the end of our playoffs here. Question for you. How many Warrior Mums can be made? What is the limiting reactant and what is the excess reactant? So Warrior Mum is depicted on the top left-hand panel. It's got a red carnation, 2 black ribbons, a white triangular ribbon, and at the bottom, a spear or an arrow, or whatever you want to call it. So let's figure out how many Warrior Mums can be made. So here's one. 2 black ribbons, white, at the bottom of the sphere. So I got one Warrior Mum. All right, let's see if we can make another one. All right, there's 2 Warrior Mums. Can I make a third? Oh, no, I can't. I ran out of black ribbon. So my question would be, I can make 2 Warrior Mums. What is my limiting reactant? Which one ran out first? That would be the black ribbons. And then what is the excess? You could say the red carnation, the white ribbons, or the 2 spears. Spears. Wow. So how do we determine the theoretical yield from the limiting reactants? Well, the theoretical yield is the maximum quantity of a product if the reaction works perfectly. And it's based on your limiting reactant. So let's take a look at an example of what that means. We're going to get a pen here. So in today's lesson, we're not really doing anything new. We're still doing stoichiometry problems here. So I want to identify the limiting reactant and the theoretical yield of phosphorus acid, H3PO3, if I have 225 grams of PCl3 mixed with 123 grams of water. So I'm actually going to set up 2 stoichiometric equations or conversions here, where I start with PCl3 and I want to get to H3PO4. And then my second stoichiometric equation will be I want to start with water and I want to get to H3PO3. So it's going to look something like this. 225 grams of PCl3. I'm in grams and I have to convert to moles because I need to use the mole ratio. That's the only way you can convert from one compound to another. So the molar mass of PClO3, if I look at the periodic table, phosphorus is 30.97. And then I have 3 chlorines at 35.45. So I get a molar mass of PCl3 at 137.32 grams. So that goes on the bottom. Oops. And that's 1 mole of PClO3, or PCl3. I'm in moles. Now I can use the mole ratio. So looking at my chemical equation, I'm going to look at the coefficients. I'm in 1 mole of PClO3. If I look here, the coefficient there is 1. So it's going to be 1 mole of PCl3. I want to get to H3PO4. So I look here, it's 1 mole H3PO4. Now, they want us to figure out the theoretical yield, and we're going to assume they want it in grams. So I have to set up one more conversion factor to convert moles of H3PO4 to grams of H3PO4. And the only way you can do that is by using the molar mass of H3PO4. So phosphorus is 30.97. I have 3 oxygens at 15.99 plus 3 hydrogens at 1.01 each. So I'm just going to quickly calculate this. And I get 81.97 grams. Okay, notice that my units will all cancel out. Grams of PCl3 cancel out. Moles of PCl3 cancel out. Moles of H3PO4 cancel out. And I'm going to be left with grams of H3PO4. So multiply across 225 divided by 137.32 times 1 divided by 1 times 81.97. I get 134.3 grams. All right, there's one stoichiometric equation done. Now the other one, I have to start with water, 123 grams of water. So I'm in grams of water. I got to convert to moles of water because I need to use the mole ratio. So 1 mole of H2O. The molar mass of water is 18.01. I'm in moles. Now I can use the mole ratio. I look at front of the coefficient in the chemical equation. Ooh, it looks like I got 3 moles of H2O. And I want to get to H3PO4. So that's 1 mole H3PO. Sorry, I said 4. PO3. And then my last conversion will be from moles of H3PO3 to grams of H3PO3. And I'm just going to use the information that I have above in the first stoichiometric equation. I just realized I wrote 4 again. All right. Molar mass of H3PO3 is 81.97 grams. So 123 divided by 1801 times 1 divided by 3 times 81.97. I get 186.6 grams of H3PO3, not 4. Okay. Cool. I've set up 2 stoichiometric equations. What in the world am I supposed to do with this? Okay, remember, theoretical yield is associated with the limiting reactants. So my theoretical yield will be the lowest value of these 2. So if I take a look at 134.3 and 186, well, 134.3 is lower. So my theoretical yield will be 134.3 grams of H3PO3. So I have my limiting reactant, or sorry, my theoretical yield. Now I need to find my limiting reactant, which I'm going to abbreviate as LR. Your limiting reactants is associated with theoretical yield. So I look at the lowest here and I say, what compound did I start with? And if I look, I started with PCl3. So my limiting reactant will be PCl3. Now on some of your homework questions, they might ask, what is your excess? Your excess would be the one that had the greater product. So in this case, water would be my excess because I have more of it. Okay, there's one example. Oh, gotta delete this. All right, I'm back. Okay, so here is another problem. I'm still using the same equation, but this time I'm in moles. And I kind of like this because that means I don't have to mess with the molar mass for the first conversion factor. So you're going to set up your 2 stoichiometric equations with your givens. So in one of them, I have 3 moles. Oops, thought I had a pen there. 3 moles of PCl3. My other one, I'm going to start with 3 moles of H2O. All right. Being that I'm in moles, I can jump right into the mole ratio. So my mole ratio coefficient in front of PCl3 is 1 mole PCl3. And I want to get to hydrochloric acid. So take a look at hydrochloric acid. It'll be 3 moles of HCl. Now they want grams of HCl. So I'm going to set up one more conversion factor with 1 mole of HCl at the bottom and the molar mass of HCl at the top. Chlorine at 35.45 plus hydrogen, which is 1.01. I get a molar mass of 36.46. All right, there's one stoichiometric equation done. Water. Set it up. Look at the coefficient. I got 3 moles of H2O. I want to get to hydrochloric acid. 3 moles HCl. Convert moles of HCl to grams of HCl. 1 mole of HCl is equivalent to 36.46 grams of HCl. Okay, let's do the top one here. 3 times 3 divided by 1 times 36.46. I get 328.14 grams of HCl. For the bottom one, 3 times 3 divided by 3 times 36.46. I get 109.38 grams of HCl. I'll change my pen color here with purple. So my theoretical yield, that's your lowest outcome, or your lowest grams. And in this case, 109 is my lowest amount. All right, so my theoretical yield would be 109.38 grams of hydrochloric acid. What is my limiting reactant? Well, I go, hey, this is my lowest. What did I start with? I started with water. So water will be my limiting reactant. And if the question asks you what is your excess, you go, oh, this one's the greater one. So it's PCl3. Okay, let's do this one here. Identify the limiting reactant and theoretical yield in grams of hydrochloric acid for each of the pair of reactants. Here I have one that starts with moles, and here I have one that starts with grams. So I'm going to set up my two stoichiometric equations. 1 mole of PCl3, and I have 50 grams of H2O. All right, this one's easy, this top one here, because I'm in moles and I can jump right into the mole ratio. So I have 1 mole of PCl3 at the bottom, and I want to get to hydrochloric acid. So 3 moles on top. I'm in moles of HCl. Got to get to grams of HCl, so the only way I can do that is by using the molar mass. Molar mass of hydrochloric acid, if I remember right, was 36.46 grams of hydrochloric acid. There we go, that one's done. Down here, I have 50 grams of water. I need to get to moles, so I need to divide by the molar mass. Molar mass of water was 18.01. That's equivalent to 1 mole of H2O. I'm in moles. I can use the mole ratio. Look at my chemical equation. 3 moles of water, and the conversion would be 3 moles to HCl. My last conversion will be similar to the one above, where I have 36.46 grams of HCl at top, and that's equivalent to 1 mole of HCl. All right, let's punch this in our calculator. 1 times 3 times 36.46, I get 109.38 grams hydrochloric acid. Down at the bottom, I have 50 grams divided by the molar mass of water at 18.01 times 3 divided by 3 times 36.46. I get 101.2 grams of hydrochloric acid. All right, change pens. I'll go to green. Money. Okay, here we go. Theoretical yields. Which one's your lowest? 109 or 101? Well, it's 101. So my theoretical yield is 101.2 grams of hydrochloric acid. Got a point there. What is my limiting reactant? Well, what did I start with for this lowest value? That would be water. What is your excess? That would be, here's your greater number here. I look at what I started with, and that would be PCl3. Okay, so that's today's lesson on theoretical yields and limiting reactants. Okay, so here's part 2 for chemistry. We're going to take what we just learned with the theoretical yield, and we're going to apply it to the actual yield or percent yield. So the actual yield is what you actually get in the experiments. It's always less than the expected. You know, theoretically we should have gotten this value, but we actually got less due to human errors or side reactions that are occurrent. So the equation for actual yield is percent yield equals actual yield divided by theoretical yield times 100, and that's because our answer will be in a percentage. Oh, shoots. Okay, so determine the limiting reactant, the theoretical yield, and the percent yield if 14 grams of nitrogen gas are mixed with 9 grams of hydrogen gas, and I create 16.1 grams of ammonia. So here's my chemical equation. It's balanced. First, let's find our limiting reactant and our theoretical yield. So I started with 14 grams of N2 and 9 grams of H2. So I'm setting up my two stoichiometric equations to find my theoretical yields, because I need it for the equation to find my actual yield, slash percent yield. So I'm in grams. I got to get 2 moles. The molar mass of N2 would be 14.01 times 2 at 28.02. That's equivalent to 1 mole of N2. I'm in moles of N2. Now I get to use the mole ratio. And if I look here, it's 1 mole of N2. And I'm trying to get to NH3. If I look here, it's 2 moles of NH3. And I got to go one more conversion factor to get to grams. So the molar mass of NH3 is 14.01 plus 3.03. And I get 17.04. Okay, my second stoichiometric equation, I'm in hydrogen gas. So I got to get 2 moles. So the molar mass of H2 is 2.02 grams of H2 is equivalent to 1 moles of H2. I'm in moles. Now I can use the mole ratio. If I look here, 3 moles of H2 on the bottom, so it cancels out. I'm trying to get to 2 moles of NH3. Convert moles to grams by multiplying by the molar mass. Wow, my pen is spazzing out on me here. 14 divided by 28.02 times 2 times 17.04. I get 17.02 grams of ammonia. For the bottom, 9 divided by 2.02 times 2 divided by 3 times 17.04, I get 50.6 grams of ammonia. Okay, so now that I've calculated my little stoichiometric problems out, I can find my theoretical yield. My theoretical yield, remember, is the lowest. In this case, it's the 17.02. What is my limit in reactants? Well, the lowest is 17.02. I look at where I started with that. So nitrogen gas is my limiting reactant. Now they want to find the percent yield. So if I go back to the previous slide, percent yield is actual yield divided by theoretical. Well, they give me the actual. The actual is right here, the 16.1. So I'll put it here, 16.1 grams divided by my theoretical. Here's my theoretical yield, 17.02 times 100. So 16.1 divided by 17.02 times 100. My percent yield is 94.6%. So by finding my theoretical yield and the actual yield that they gave me, I calculated the percent yield at 94.6%. Okay, now this one's a little bit different. They're giving you a percentage. So if you remember what our equation is, it's percent yield divided equals actual divided by theoretical times 100. Well, they're giving me my percent yield, 80%. Okay. Suppose that the percent yield of BrCl is 80%. How much BrCl can be made by reacting 338 grams of Br2 to 177 grams of Cl2? I have to set up 2 stoichiometric equations to find my theoretical yield. I'm going to use a different pen color for this. So I have 338 grams of Br2. I need to convert grams to moles. Molar mass of just 1 Br is 79.91. Take that times 2, I get 159.82 grams of Br2. Okay, I'm in moles of Br2. Now I can use the mole ratio. Oh no, they didn't give me a problem. Okay, we're back. I forgot to include the balanced equation, which is in red above. I apologize for that. Okay, moving on here. So the mole ratio. If I look here, I have 1. And I'm trying to get to BrCl. I have a 2 here. Now I've got to convert 1 mole of BrCl to grams of BrCl. So bromine is 79.91 plus chlorine at 35.45. I get 115.36 grams of BrCl. Okay, my second stoichiometric equation is chlorine. Divide by the molar mass to get to moles. I can use the mole ratio now that I'm in moles. That's supposed to be a multiply sign. If I look here, it's a 1. Here, there's my 2 moles. Convert moles to grams. All right, let's punch this in our calculator. 338 divided by 159.82 times 2 divided by 1 times 115.36. Get a big number of 487.9 grams of BrCl. The bottom equation, 177 divided by 70.9 times 2 times 115.36. I get 575.9 grams of BrCl. All right, change pen colors here. My theoretical yield is the lowest. In this case, it's going to be 487.9 grams of BrCl. My limiting reactant would be Br2. Now, they want to know the actual yield. So I found my theoretical. So I'm going to go back to my original equation. My theoretical is right here, 487.9 grams. Actual, that's what I'm solving for, times 100. So if I take 80 divided by 100, I get 0.8. Oh boy, I'm out of space here. Okay, I am just going to erase this. Go back to my pen. So I have 0.8 equals A divided by 487.9 grams. Well, to get rid of that, I multiply by the reciprocal. So 0.8 times 487.9, my actual, and I'll put it in a different pen color. Oh man, I am just running out of space here. My actual, I get 390.3 grams of BrCl. And I got that from here. Okay, so sometimes they will, if I go back to this previous example, they'll give you the actual, and you have to find the theoretical, take your actual divided by theoretical, you get your percent. Sometimes they give you the percent, and you kind of have to work backwards a little bit, but you still have to find your theoretical, and then you'll just solve for the actual instead. Okay, that's not your assignment. Your assignment is the worksheet that I did attach. On Friday, it will be a work day. It will be page 319, questions 6 through 12. We will have a quiz on 9.2 on Monday. Okay, so then I had that on the whiteboard. It's no surprise. So if you're gone for whatever you're gone for, we will have a quiz Monday. Okay, good luck. You can email me questions if you're having problems.